started with one core problem, and the core problem was simple. How do we help women commute safely across the region? That was why we created Grab 6 years ago.
We are in the most exciting, most dynamic space there is. Ride-hailing was actually the fastest growth among internet users.
We're in about 1 in 7 smartphones across Southeast Asia. Beyond mobility, what can we do for you? Our vision has gotten bigger. Our mission has gotten much bigger. We actually felt that, hey, that's not enough. We're actually even better at creating millions of income opportunities.
Tanahnya kering, jadi banyak yang nganggur. Jadi agen kudo, kita bisa jual pulsa, listrik, bisa nabung beli motor.
But that's not enough for us. 6 million is not enough. We believe we can go from 6 million to 20 million, from 20 million to 50 million, from 50 million to 100 million micro-entrepreneurs. That is our vision of this part of the world. We together can really take millions of people in this part of the world and move them to a new economic reality.
How do you win customers? It's not by thinking, hey, I can only serve them with transport. You can't. You need food, you need payments, you need logistics, you need hyper massive localization.
And since then I have been working full-time on doing research and building application on top of Ethereum as well. I think we brought Ethereum meetup to Vietnam 2 years ago, and back then it was a small meetup. But it's great that we can see a lot of people coming to the meetup today. Yeah.
Thank you. Mr. Thanh, you want to say anything?
Hi everyone, I'm Thanh. So currently working as a CSO of an internet company in Vietnam, and also recently I also found a blockchain company working on a couple of solutions for using blockchain. And I think my background is basically on security, and for the history of starting from blockchain, I think I start around about 5 or 6 years back, and hopefully I think today we can we can listen to a lot of the update from Ethereum from Vitalik as one of the father of Ethereum, and hopefully we can have some his opinion on the future of blockchains. I think that's what I really expect to know more about his opinion today.
Yeah. Now, Vitalik, please tell a few words to our communities. And
I don't know, what should I talk about?
Sharing about I think later on, then there's coming several questions.
Mm-hmm.
So for now, then I think that if you want to say anything to our communities.
I don't know, what should I say?
Let's say hello.
Xin chào.
Oh, wait. I think that for many of us here, although they can know about the blockchain, but also there are several people who really not understand well about the blockchain, especially for recently movement in the industry. So from your point of view, then can you briefly update us about the current situation of the blockchain industry?
The current what version?
Situation, current
situation.
landscape. Yeah.
I heard city version. Yeah, so I feel over the last maybe 1 to 2 years, the blockchain community has clearly grown by a very large amount. 2 years ago, you would not have seen meetups like this, even in cities in the United States. And now it's much bigger everywhere. And I mean, there's like a lot more people who are interested in blockchains, interested in cryptocurrencies, interested in like the idea of decentralized applications. So, I mean, just in size, the community has grown a lot. I mean, obviously there has been kind of interest, especially in 2017, because that's when the prices were going up. But like, even aside from that, there has been a large amount of like technological progress. So for example, like inside of the Ethereum space, there's been work on state channels, plasma, sharding, Casper, different kinds of scalability and security technologies. There's been a lot of development of different kinds of applications on blockchains. There's been kind of interest both from kind of individual developers and small companies, also kind of large companies as well. There's been kind of growing interest in kind of going beyond just cryptocurrencies and seeing kind of what other areas and blockchains can be applied in. So, so some of the areas that I think saw a lot of progress include like decentralized exchanges, is trying to just make it easier to kind of exchange between different assets, different forms of crowdfunding, obviously. There's been some growth in kind of using blockchains for applications outside of finance, so kind of keeping track of like records for different industrial applications like internet, social media things, and so forth. But like that space still hasn't seen as much adoption. In my opinion, like one of the big reasons why is that transaction fees on blockchains are still very high. And over the last 2 years, they have actually gotten higher, right? So like because there has been so much demand, transaction fees on Ethereum, I think, went up from like less than 1 cent to, you know, like more than like 50 cents. Now they're maybe at 5 cents. And those kinds of fees are kind of okay for financial applications because people are kind of already used to high levels of inefficiency in financial systems, but just regular things on the internet, right? Like people aren't used to like paying 5 cents to make a tweet, right? So like just those kinds of limitations I think are still kind of holding back adoption to some extent. A lot of what my presentation there is going to talk about is that there's been a lot of progress in kind of scalability and a lot of progress in kind of base layer scalability technologies. So not just things like Plasma, but also kind of upgrades to the base chain itself. And I feel like one of the big changes that has happened that will kind of continue is that there has been kind of a growing shift from just theory into kind of practice. So into like, you know, like there are companies like mainstream payment processors, mainstream banks, and all trying to understand like how do we take this technology and like build things that are like actually useful and like actually starting to build things, right? So like one of the kind of categories of blockchain applications in industry that I find interesting is this idea that, you know, instead of having kind of different silos for different companies, you can create a kind of common shared network that allows for kind of interoperability within one industry. So this is useful for this could be useful for payments. Because, you know, there's a lot of kind of interoperability problems between even just different kind of mobile e-wallets. It could be useful for like train and hotel bookings. It could be useful for like stuff around supply chain like tracking. So there's a lot of areas like that where I think, you know, the technology could be valuable. But then there's also just like things that are kind of less institutional and more just kind of individual developers. So things like even just cryptocurrency by itself, things like, you know, like decentralized social networks, things like decentralized alternatives to internet protocols like mesh networks, and all sorts of cool ideas that kind of combine blockchains together with other technologies. I think it's very promising. A lot of progress on privacy over the last 2 years. So things like zero-knowledge proofs, for example, 2 years ago, completely theoretic. today Zcash exists, and there have been kind of successful tests of using zero knowledge proofs to secure transactions on the Ethereum mainnet. So a lot of progress, but it's still kind of a lot of progress on the theory. I think the main thing that really remains is kind of work on the user interface level, so making the stuff easier to use. And that's something that I think the space needs to work harder on the next 1 to 2 years.
Okay. Yeah. Do you want to add on?
Well, I guess it covers everything already. So. Yeah, so I think I just want to add up a little bit on top of what he just shared. So I think we still have a lot to do in terms of like making blockchain easier to use for developers as well. So we talk a lot about like making it user friendly, but we haven't really like put enough attention to the mainstream developers. Like how do we like allow people to build application easily on top of Ethereum or even like Bitcoin as well. That's why we started this Ethereum Hanoi meetup to focus on developers, and we're trying to do it like once every 2 or 3 weeks. Yeah.
Okay, cool. I understand that now Kyber is like one of very few application that I think you can say bravely running on-chain Ethereum. But like a lot of people talking about like the scalability problems, and they're afraid that like running an application on-chain is like gonna be a big issue then. However, I think Nelo is very I think that very brave and very keen and believe on the future of Ethereum. So can you guys share about like how you guys work on it, work together to solve the problems that like from your side, and you are the foundations, and from the side his application want to prove that Ethereum can be useful. So like how you guys work together to solve the problem.
I mean, I think that like blockchain, the kind of core Ethereum community itself and kind of individual projects both have a lot that they could do to improve scalability. So like on the kind of core blockchain side, I mean, there's like a combination of short-term and long-term strategies. So like in the long term, for example, like things like sharding and like things like plasma and like some of these like different scalability constructions are kind of eventually the way to go. But then in the shorter term, there's also kind of other kinds of efficiency improvements that can be made in protocol, right? So one example of this would be something like even like something very simple like precompiles, right? So the idea here is basically that if there's some kind of cryptographic operation that a lot of people like needs to be able to do on chain, so this could be like verifying signatures, verifying zero knowledge proofs, kind of very complex things like that, then instead of kind of everyone having to run it inside of the EVM and get a lot of inefficiency, we can create a kind of blockchain, like basically add a kind of specialized opcode into the Ethereum protocol that lets people do that automatically, right? And this way you can kind of reduce the cost for running these operations by quite a bit. So because this was done for elliptic curve operations, like using like the scalability of applications that use zero knowledge proofs is now like suddenly possible, right? Before it was not possible, and now it's possible. In 2016, there was also a new kind of zero knowledge proof protocol. So this is a kind of fundamental kind of computer science advance that was made. And theoretically, this reduces the gas cost of verifying a zero knowledge proof from 1.9 million to maybe 500,000, right? So like these are examples of short-term things that we can do to make like improve the scalability in this case of like privacy preserving applications. First from like completely unusable, then to 2 million, then by another factor of 4.
So I think that like do you have like any experience, any lesson that that you can share to like the community here on how you, because like when you run your application on Ethereum, you face a lot of problems, right? And the limitation and how you can solve that problem, how can you create a kind of like the channel to Ethereum's communities and to solve that.
Yeah, so I think I mean, because first of all, blockchain and cryptocurrency are new, right? Smart contract are new as well. So it takes some certain level of like education for the users, and sometimes I think that's the major problem that we have in decentralized application space. In terms of like the underlying platform, I think certainly we should make it faster. We should make it like more scalable, make it cheaper for the users to use as well. That will certainly like improve the user experience for the for the applications. One thing that is great about Ethereum and Ethereum community is that everything is sort of like community driven in a sense. Like you can submit proposal to even to the developer, saying that you have some certain need and good like the developers or the core team to address it. And I think it will be like brought up during the discussion, and will be implemented in the next upgrade. Yeah.
I have a question that for Ethereum as a foundation to become like popular platform, but a lot of people talking about like blockchain is gonna be a future of internet, right? So to be like popularly like adopted, then Ethereum is not only a protocol, but it should have like some like key application on that, running on that. So from your point of view, Vitalik, then what are the applications that you think is the key application for Ethereum?
Yeah, I was about to say decentralized exchanges are very important. And aside from decentralized exchanges, I would also say and privacy-preserving solutions are fairly important, like oracles for different kinds of data. So trying to allow smart contracts to kind of do things based off of real-world data more easily. Different kinds of currencies, so including things like stable coins. What other very useful ones are there? It's not so much an application, but like we need like secure wallets, I think, are very important. So like including kind of vaults, like different types of multi-sig wallets, and kind of all of those ideas. Like we need more secure ways for users to interact with the blockchain.
I think very interesting that you mentioned about the secure wallet, because before then people who are the wallet user facing a lot of problems. Either they are like theft, right? Someone like take the money out of their wallet, or like they forget all of the like privacy key, right? And they lose all of the money inside. So like as a security expert, Mr. Thành, then what do you think about the current challenges for the securities in the blockchain industry now?
So previously, like I'm start a company called Verichange Lab. So it's actually a lab working on solving a couple of different security issues in blockchain. So I think because it's involved into the cryptocurrency, so basically it's your money. So the good part of like cryptocurrency is actually you don't need to depend on central bank or whatsoever to control your to keep your money, and you need to be responsible for to protect your own wallet. But it's also a problem that the average user normally not really able to protect their own money, right? So one of the product where we are focusing on is to build a secure wallet for cryptocurrency, where we're trying to bring like a couple of different ways to protect user into the wallet. So I think that's one of the things very important, like Vitalik just mentioned, that in order to have the wider adoption of using cryptocurrency at the daily uses or for business, the security of wallet is one of the very key important things, and we need to be solved. And also, I think in terms of the usability, how is especially in terms of like when it's increasing usage of decentralized app, you will need to have a way to interact with application, right? And normally, in order to do that, you will need to have the private key somewhere, either on your browser, on your hardware wallet, on your mobile DApp browser or something like that. And it's actually increasing the surface of attack, where it's easily more easy for you to lose your private key with your money. So I do believe that there is a space for innovation in terms of how to bring security and usability and the widely adoption of using cryptocurrency to the mass, to the customer. Yeah.
Yeah, I think that for the blockchain industry to approach the standard level of the other industry like banking, for example, is still there's a big gap, right, for the people to fulfill. For example, now if I have a bank account, then every time I withdraw money or I pay something, then there's a notification onto my mobile phone, right? But if I have a wallet, a currency wallet, right? And there's nothing happen. I don't know what's the amount out there, except I have to go to the app and check it, right? So now people talk about frankly, some people talk to me that Ethereum we haven't seen so much major milestone in the development of something new practice or something breakthrough on the technology in Ethereum recently. So can you update us about the progress of Ethereum developments and when the plasma and the sharding happen? Yeah.
Concrete progress that kind of has happened over the last maybe 6 months. So number one, state channel frameworks have now been released, and state channels are already being used by some live applications to increase their scalability, right? So ConnectX, I think, or Connect launched a state channel framework. And I know SpankChain is using it. I believe other state channel projects are starting to use it as well. So that's something that exists now, is alive now, and was not there 6 months ago. The general state channel framework from L4 also available now, not available 6 months ago. Plasma is not yet released, but OmiseGo has a testnet. The Loom network I know is definitely making a lot of progress toward launching. There has been a lot of kind of improvements on Plasma designs. So, for example, the idea, unfortunately I can't say it because the idea behind Plasma Cash was invented, I think, March 8th, which was just before 6 months ago. But improvements to Plasma Cash, Plasma Debit is probably a big one. Privacy technologies. So there is a developer called Barry Whitehead who has been releasing kind of ongoing proof of concepts, basically using zero knowledge proofs on Ethereum to do privacy preserving token transfers, privacy preserving voting, just different kinds of privacy preserving applications. So a lot of this has happened over the last 6 months as well. Casper development, so the Casper spec is now very close to finished. Not at all true 6 months ago. Sharding, making a lot of progress. Casper now has kind of multiple development teams that are all actively implementing the spec, and it's getting kind of closer and closer to a testnet. Viper has, I think, the new programming language has, I believe, released a beta, and it'll kind of officially. I know there is at least one application based on it that's intending to launch within 2 months. So, on the kind of usability side, I know there are many teams working on wallets, and I personally know that there's much more activity than there was even 6 months ago, but none of that has kind of really released yet. Well, Status has made a lot of progress. Status is now kind of available as a beta. So, altogether, I do think and there have been kind of a lot of things that happened in the space even over the last half year, and there's even more in development.
Okay. So like in terms of like specifically, then when do you see there's a mainnet for like plasmas and
Mainnets for plasma, I think. I mean, I hope to see that we start seeing them in the next few months. I believe so, yeah, but we'll see. Like, plasma is also a very flexible technology, so we'll probably start with fairly simple versions of plasma and then make them more and more complex over time.
Okay. What are the measures like technology challenge for you to release those kinds of improvements?
Major technology challenges. Let's see. I think, making a kind of proof of stake protocol that works well is one, but like we've made a huge amount of progress there. Like I feel like we have one that kind of combines a large number of fairly kind of close to optimal properties now. There's been, right now, like, the challenges aren't really fundamental research challenges anymore. They're more kind of incremental development challenges. So like one of the big ones right now, for example, is working on the peer-to-peer network. Because when you make a sharded blockchain where like you can't just create a gossip network anymore, right? Because by definition, there's too much data for a single computer to download. And so that requires like a very non-trivial amount of work on the peer-to-peer side to actually make work well. And like we have already made a lot of progress on that.
Okay, cool. Also, there's a like, story and people saying that given now you based on the proof of work Ethereum mainnet, and now you change to the proof of stake, right? Does it mean that the people who run the mining farms now they have to change the infrastructures? And if that's the case, then how do you like manage the changing? Yeah.
Well, so after proof of stake, there basically won't be miners like anymore, right? So. Like, I know that some of the mining pool operators have already started on, like, thinking about getting into making proof-of-stake pools. I know, I mean, realistically, like, I do think miners will continue to have, like, could have some role. So, like, one example of this is, like, running nodes for, like, running watchtower nodes for channel networks, running watchtower nodes for plasma, kind of third-party infrastructure to prevent kind of users from needing to be online. Another example is that, like, generating zero-knowledge proofs, because generating zero-knowledge proofs does require like a large amount of computational effort, and so you could imagine a protocol where miners are kind of paid to produce those. I mean, but like even between all of these applications, right? Like the total kind of amount of work that there will be for miners to do will probably be maybe 100 times less than today. So. Like, realistically, you know, like this has been kind of known all along, that I do think the kind of proof of work industry will get much smaller.
Okay. Is there anything that, like, I think it's a very important topic because we addressing the development of Ethereum. So from your side, in Thai, do you have any like comment on the development progress of Ethereum?
Yeah, I guess as I mentioned earlier, right? Most of the discussion are public on ETH research and even like on Reddit as well. So if you wanna, you know, get a closer look and follow the progress better, you can just like, you know, go to these platforms. Yeah.
Yep. Yeah. So I think the comment is like you need to look like closely to the GitHub, right, to understand the progress of the Ethereums. Also, I think that like pretty interesting to me. Like you said that only a few months more, and we can have like the first plasma testnet. It's very promising to the communities. However, like from now to then, given like the limitation of the technologies in the blockchain industry, do you have any anticipate on like how's the industry look like, how the people will like react? Because you know, like before the developer they come to the industry, I think that beside the love of with the technology, but I think that the most important part also because of the hype on the cryptocurrencies. Now it's not there anymore. And still we need to wait for the development and for the like progress on the Ethereum to have another hype. So what do you think that as a creator of Ethereum, what do you do to keep the momentum still there?
I mean, I've been in the crypto space for 7 years. I've lived through kind of 2 crypto winters, and this is my 3rd. And from my experience, crypto winters are where the real work gets done, right? Like, you know, people aren't kind of rich enough to waste their time like partying in the Caribbean instead of getting actual work done. There's like the media focus is at least like once things stabilize, like less on kind of prices and on projects raising big amounts of money and more on like actual technical development. And the people that are in the space like for kind of the right reasons, the people that are in the space because they kind of believe in its values and its ideals, and they are ultimately like going to be there, whether the number of developers is like 10,000 or a million, whether the price is 1,200 or 200 or 12, and they're like. So I think it is just important to just kind of keep on focus, like kind of keep your focus, keep working on the tech, and at some point, if our ideas about blockchains kind of being useful in the first place are correct, then once the tech gets good enough, then people will use it because it's useful.
Okay. Yeah. So I think that now I don't want to like take like too much time by asking my own questions. So if you have any question, then please raise your hand and yeah. Please.
I have a question for Vitalik. Before you mentioned that paying a transaction fee for a tweet, for example, is kind of unrealistic. Is Ethereum doing anything to reduce and/or eliminate transaction fees?
So because of like supply and demand economics, right? Like the only way to reduce transaction fees is to increase supply. And supply in this case means the number of transactions that go into a block, right? Because if we try to like push transaction fees down without increasing the size, increasing the block size, then like demand will exceed supply, and like a large number of transactions will just not be able to get in. So in the long term, that problem is the exact same problem as the problem of solving scalability, which is what plasma and sharding and things like that are for. Although I will say there are kind of some exceptions. So for example, I wrote a paper on resource pricing about a month ago that talks about how you can kind of just using changes to economic incentives make the transaction fee market work more efficiently. Because, like, for example, right now, right, the median transaction fee sender actually pays 3 times more than the lowest transaction fee they needed to pay to get in the block, and the average transaction fee sender pays 5 times more. So there are, like, because of how first price market auctions work, there are these fairly kind of large inefficiencies, and even without improving scalability, there are ways to kind of address them to some extent, which we are very actively looking into.
So if you look at the growth of Ethereum, it has been growing incredibly fast, and you're looking at scalability issues to increase that growth, to make it go even further. Is there any limit you have in mind to the growth of Ethereum? Like, should it at a point overtake everything, overtake the traditional financial system, overtake maybe even other cryptocurrencies? Do you have any vision on that?
So, I mean, after sharding, the possibilities for Ethereum's kind of transaction capacity will definitely increase significantly. Like, I think with sharding and with a lot of technical optimization, you can probably eventually get to like 100,000. And then above that, like if you want even more, then you can use layer 2 protocols on top of that, and that's how you kind of get into the millions. So, like, I personally do feel like, theoretically at least, kind of level 1 blockchain scaling times increases from level 2 scaling is enough to like basically handle the world, like the world's kind of level of a need for like basically a transaction capacity. But at the same time, that doesn't like, High CoinDesk, High Cointelegraph. I definitely did not say that this implies that all of the world's activity actually will be on blockchains, right?
Right.
Because there are like very good there are plenty of applications where there isn't that as much value for them. There's plenty of applications where just for whatever reasons people won't deploy them. There's going to be other blockchains. So I definitely do feel like we the Ethereum can eventually be sort of technically capable of absorbing as much activity as it needs to, but that's not the same as a prediction that that'll actually happen, right? Like for that, there's a lot of things kind of other than just technical that the community needs to work on.
Right. Awesome. Thank you so much. Positive and realistic. Will you ever come to Blockchain Meetup Hanoi? Will you ever come to Blockchain Meetup Hanoi when you're back in Hanoi? It's a meetup. I founded about a year ago. You are very, very welcome to come anytime.
Okay, thank you.
Cheers. Thank you.
So there are multi-sig wallets on Ethereum already. I think the main kind of complaints that I see is that, first of all, because there is this kind of two-class system between like native wallets and and kind of contract wallets, and contract wallets are still kind of not perfectly easy to use. And in Ethereum 2.0, the kind of our abstraction plans are probably going to change that. The other thing that people complain about is that, like with contract wallets, there's the risk of bugs. And I think our solution for this will probably be to just kind of create a standard suite of wallet contracts and like basically get them audited and formally verified so that they're kind of secure enough that people would be willing to trust them. Well, it depends on what your question is, I guess, right? Because like as I said, Ethereum supports multisig already. The question is just how. And like the kind of quality of the support will improve.
Yeah. Okay. Thank you. I think that after this, then Vitalik will have a presentation about in detail about like development of Ethereums, and also I understand that you have to leave to the airport on 3:30, right? So I think that for the coming question, then we need to wait after the presentation. Is it okay? So you're gonna present. Thanks.
Is there a clicker thing? Okay. Cool, thank you. So what I basically wanted to go through are kind of some of the recent new progress that has been happening in kind of Ethereum research and development, and a lot of this stuff like has actually like basically happened, you know, like within like the last 6 to 9 months within 2018, right? So the kind of rate of progress I feel has kind of very significantly accelerated, you know, like since the start of this year when prices stopped going up and started going down. So there's kind of a few different parts to what we call Ethereum 2.0, which and when I say Ethereum 2.0, like I generally refer more to kind of base layer changes that will happen to the Ethereum protocol. So including things like proof of stake, including sharding, including like protocol level efficiency upgrades. But what this does not include is all of the work in kind of privacy preserving solutions, state channels, plasma, like all of which by themselves are very valuable, and many of which I actually think will be ready even before any of this you know, comes, maybe even has a test net, right? So to start off, proof of stake, right? So this is kind of the consensus algorithm, the alternative to proof of work. So for if anyone wants, like, one of the kind of nice things about the Ethereum community, as like mentioned, is that like basically all of our research, like once it's kind of gets anywhere close to being kind of stable enough to to be worth talking about is basically available somewhere online, right? So like most of these slides will have these links at the bottom, and feel free to take pictures and then like painstakingly type the 30 letters into your web browser by hand. Sorry about being too lazy to use Bitly or whatever. This is the kind of Casper Uncharting Chain 2.1 spec. So this is the latest version of the spec for the kind of Ethereum chain that is based off of pure proof of stake. So before Casper FFG was kind of hybrid proof of work, hybrid proof of stake. And earlier this year, we made this kind of pivotal decision that I think like some people don't like because it really delayed launch. But like I think in the long term, it was the right thing to do because like in the long term and like after 1 year, it really does reduce the amount of kind of effort duplication that we have to do, which basically is that instead of taking a hybrid proof of work, proof of stake approach, we just separately make a proof of stake chain, and we kind of launch the proof of stake chain, and the proof of stake chain kind of has this one-way connection to a proof of work chain, but otherwise it's fairly independent, right? So this is uses a combination of kind of PBFT inspired proof of stake. So basically the same kind of philosophy as Casper FFG, but with some kind of efficiency improvements, combines it together with kind of Ghost as a fork choice rule, and this gives some nice kind of properties that we'll talk about later, but basically this is kind of highly optimized and like highly efficient proof of stake, still with a kind of very high, like very decentralized, very high validator count. Plan to support like potentially 1 million validators. And if anyone wants to kind of read through the spec, it's basically here. There is an implementation of this in Python, I think at like GitHub Ethereum beacon chain. And it is pretty far along, right? So this is basically a kind of standalone proof of stake design, and if you want, you could even just build a blockchain out of it, or you could use this to secure a private chain, along with a bunch of other things. One of the kind of important scalability technologies that was used here is aggregate BLS signatures, which basically allows you to take a large number of signatures from a large number of validators and kind of combine them together so that for every kind of additional validator whose signature you needs to process, the additional space requirements are only 1 bit, and the additional time requirements are maybe 1 over 1,000, like 1 elliptic curve addition, so maybe 1 over 1,000 of a standard signature. So it becomes like a very efficient way to handle thousands of validators, right? So this is one thing. There is also a kind of version of the spec which is, I mean, it's also a draft, but it's kind of designed for kind of something closer to academic audiences, where basically instead of talking about like serialization formats and very fine-grained details, we just describe it more in terms of kind of mathematical properties, keep it very compact, and kind of be more explicit about what the security claims are. So Ghost fork choice rule. So basically, the Ghost fork choice rule was kind of originally invented for proof of work by Aviv Zohar and Yonatan Sampolinsky in 2013. And the problem that Ghost was meant to solve originally is this problem of basically if network latency is like very large compared to the block time, then how do you ensure the blockchain continues to be secure, right? Or alternatively, you can say, how do we make blockchains secure with a 2-second block time? So here we are using it in part to increase security under network latency, but also in part to kind of make the blockchain much less dependent on proposers. So the school of kind of BFT inspired, the category of BFT inspired proof of stake algorithms that we're using here, right? It does depend fairly heavily on proposers. So it depends on the idea that you have a round. During each round, there's one validator that's supposed to make a block. And the problem basically is that how do you deal with situations where, say, you get unlucky and 20 validators in a row or 20 proposers in a row are all malicious, right? How do you prevent that from turning into a situation where 20 blocks can get reverted? And Ghost actually does that, right? So one of the benefits of this is that the Ethereum chain can have a fairly high guarantee of security, even in without needing to kind of fully depend on randomness beacons, VDFs, VRFs, elliptic curve, verifiable secret sharing, blah blah blah, right? Basically, this system is secure even if the attacker chooses all the random numbers. And now, if you have a working random number generator, the security guarantees go up, but it was important to me to be able to kind of prove at least some security claim even without relying on randomness, right? So that basically simplifies the security model in many ways. And this is an actual kind of simulation. So if you go to a GitHub Ethereum research and then go into the clock disparity folder, you'll actually, you can actually run a Python file and it'll actually kind of do a simulation. And in this simulation, the network latency was, I believe, about 3 times larger than the block time, right? So this is the equivalent of Ethereum running with a network latency of 42 seconds, which in proof of work right now would completely fail, but here it does fine. So properties of the proof of stake, right? So first of all, assuming asynchronous network, so assuming a network latency of less than maybe 5 to 8 seconds, and assuming maybe less than 40% of faulty nodes, the chain kind of almost never reverts even a single block. So 1 confirmation is basically equivalent to 6 confirmations in Bitcoin, or not 10 confirmations in Ethereum, or any of these numbers, right? So basically 16 seconds and you already get very high degree of safety. Assuming less than 1/3 faulty, the chain never reverts finalized blocks, right? So this is the kind of PBFT style finality, which basically says that reverting finalized blocks is even more expensive. Plausible liveness. So this is a kind of formal claim that says that the kind of the rules of the chain ensure that the chain can't get stuck. So there's always some way to make progress, right? So if you want to understand why plausible liveness is important, I would encourage reading the Casper FFG paper, but no, we have it. Light client friendliness, and also kind of supporting validator rotation, so the ability of validators to kind of enter and leave the system. Light clients, so basically one of the nice kind of side effects of BLS aggregation is that you can basically reduce the amount of space needed by a light client. And one of the reasons why we kind of abandoned the old hybrid proof of stake and went to the full version is that when you do the math, the amount of data that a kind of quote light client needs to download in the original version every 20 minutes was 227 megabytes, which is actually not very light. And we basically reduced it to somewhere between 3 and 100 kilobytes, depending on what security guarantee you want. So verifiable delay functions, so we are basically planning on adding a kind of built-in randomness beacon into the chain, and this will be useful both for kind of enhancing the security of the proof of stake. So for example, the kind of synchronous security guarantee with a VDF, if the VDF does not work, it might be somewhere maybe around 30%, but if the VDF does work, it could go up to more than 40%, maybe close to 45, right? So the idea basically is that it's a kind of a function that allows you to kind of commit to a number, and then where nobody knows what the number is that you've committed to until some amount of time passes, and in some amount of time, anyone can calculate the result, right? So this is also useful, aside from the blockchain, we're also doing this because it's very useful for a fairly large class of on-chain applications. So including, there's many kinds of games that need random numbers. There's, in many cases, you actually want protocols that have random numbers. So for example, you can increase the efficiency of zero-knowledge proof protocols. You can increase the efficiency of crypto-economic protocols, a bunch of things. So Justin Drake has been doing a lot of good work working on this full time, and there has been a huge amount of constructions just in the last 3 months alone. So those are kind of some of the improvements on the proof of stake side. And, if you want, I have a section at the end where I'll talk a bit about development, but there has been a lot of development happening. Sharding, right? So, in general, the sharding design, hold on, what? Sorry. Basically, okay, fine. Basically, the sharding design is that you kind of break up the blockchain into a kind of constant number of partitions. So in this case, we have 1,024. And instead of requiring everyone to kind of process and validate everything, we randomly assign subsets of validators to act as a kind of code committee to vote on kind of block hashes of blocks and shards. Right, so basically you just have random committees that specialize in validating one particular subset of the data, then they validate it, and then they make a signature to attest to it, and the signatures get aggregated and published onto chain. And then if 2/3 of a committee approves a block hash, then it gets included. Right, so the idea basically is that because we're using this random sampling technique, unless an attacker takes over more than maybe 40% of the entire validator pool, there is no way the attacker can take over even one committee. Right? So this is a kind of simulation that I did actually, I think around 5 months ago. But basically this kind of shows how you have the main chain, which is in blue, and you have a bunch of shard chains. And the shard chains are effectively kind of dependent on the main chain, right? But the shard chains also have their own fork choice rule. They have these kind of links going into the main chain, which are in green. So you basically have 1,024 chains that are kind of proceeding in parallel. And when the shard blocks get into the main chain, that also serves as a kind of coordination point, which allows messages from one shard to kind of get into other shards. So one of the kind of big problems in sharding is this kind of data availability problem. And the data availability problem basically says if you have a block proposer that proposes a block, but then some of the data in the block was not actually even published, then your problem is you can't really prove to other nodes in the network that data does not exist, right? If a block is incorrect, then you can make a fraud proof. You can kind of show them the tiny part of the block that had a mistake in it. If part of a block was not published, you cannot prove to someone else that the data is not published because, like, you could claim that it's not published, but then if you make a claim, then the data could get published after. Right? So there's no way to kind of distinguish between like bad block publishers and false claims. So one of the, there has been kind of a lot of research on this. I'm working with some researchers in the UK on a paper that uses kind of erasure coding to do a data availability checking, which hopefully should be published fairly soon. But aside from that, another kind of short-term strategy that we have is this idea of what we call proofs of custody. So a proof of custody is basically a kind of claim that it's a computation that every one of the validators that votes for a block needs to make. And when they make this computation, they basically need to kind of commit or like sign one extra bit. And this one extra bit, like generally there's a 50% chance it's a 1 or there's a 50% chance it's a 0. And then after 1 month, they would need to kind of publish the private seed that they used to make the computation. And then after they publish this seed, anyone else can check their computation and anyone else can basically, like if they check the computation wrong, they can play this kind of on-chain challenging game and they can kind of prove to the network that this node did this computation wrong and that node can get penalized. So like basically it creates this guarantee that if you vote, like voting on data without checking that it's available is very, very risky, right? And if you vote on data, if you vote that some block is there when actually the block is unavailable, or without even downloading it yourself, then you can't do this computation. And so like basically it ends like you run the risk of losing a lot of money, right? So it also creates a kind of lower bound on the amount of money that nodes validators need to lose in order to for a kind of bad block to get accepted by the chain. state execution. So state execution basically means kind of how are transactions processed, right? And yes, I know the word state and execution mean different things. But like in the context of the blockchain, right? Like the state basically is kind of the set of data that like all nodes in the blockchain need to keep track of. So this could include balances, this could include smart contract code, this could include like smart contract temporary storage, like basically things that are kind of not part of the history, things that kind of actually matter in the present, right? And execution basically means like executing the virtual machine, processing transactions. So there's kind of different parts of the state execution engine that we're upgrading, right? So eWASM is a project that has been running for the last, probably the last 2 years. And the idea is to replace the current Ethereum virtual machine with a new virtual machine that is based on WebAssembly, right? So eWASM maintains guarantees of kind of determinism. So the computation is guaranteed to have the same result every time. Metering, so basically kind of measuring how much gas a transaction consumes. Small code size, security, and simplicity. The eWASM spec is kind of very simple, like about probably simpler than the current EVM. eWASM is much faster than the EVM, especially for complex computations. So, for example, for implementing cryptographic operations on top of Ethereum, the eWASM is much more kind of effective. And there is a testnet for a kind of version of Ethereum that replaces the EVM with eWASM coming very soon. So this is one part of it, right? So basically, instead of using the EVM for transaction execution, using eWASM. Asynchronous cross-shard transactions. So this is something that we've kind of known about for the last 2 years, but this is basically how to kind of send Ether from one shard to another shard, right? Like basically, you start off by making a transaction on one shard, then you kind of create this Merkle branch, you create a receipt for it, then as soon as the other shard becomes aware of the Merkle root of the first shard, you can basically kind of publish the proof that the transaction existed in the first shard into the second shard. So you basically delete 100 coins on the left, then prove to the right that you deleted 100 coins, and then on the right that allows you to kind of create 100 coins, right? So this is basically kind of the same as it has always been. Now we have been thinking about kind of designs to allow for synchronous cross-shard transactions, but the current kind of approach is probably to do that more at layer 2 than at layer 1. This is something that I think you can probably look up on ETH Research as well. Economics. So I mentioned before that I wrote this paper recently on resource pricing in blockchains, and two of the two kind of core sort of prescriptions that I have in that paper, one of them is this adjusting min fee gas price market. So this basically is a way to make the market for transaction fees more efficient and to make transaction fees less volatile in the short term. And I have some proofs for why kind of that this is kind of optimal and welfare improving and like good in all of those kind of economic technocratic ways. Another thing that I propose that we have been talking about for a long time is storage maintenance fees. So basically, if you have storage, or if you have a smart contract, and that smart contract is storing data in the state, then you don't just pay for it once, you basically have to keep on paying for it for as long as it's part of the state. And this is there to kind of encourage people to conserve state more, to encourage people to clean up, and to ensure that contracts that nobody cares about eventually get deleted. Development. So what I talked about here before was kind of mostly kind of more on the theory side. So kind of ideas in terms of protocol design that have kind of matured quite a lot and gotten from kind of very abstract ideas to something that can be kind of implemented very concretely. But then the next question is, who is actually building it? So there is this article on Medium, which is actually written by someone who is not even part of the Ethereum Foundation. So this kind of shows, like how kind of decentralized the Ethereum community's development is, right? That a very large portion of the Ethereum 2.0 work is being done outside of the foundation. And Rocket Pool is basically a company that will be doing staking pools on top of Ethereum 2.0. So who's building it? So this is kind of one way of seeing kind of what a kind of diagram view of what Ethereum looks like, right? Where you have the protocol specification, and the protocol specification is kind of being developed kind of, I mean, fairly centrally by a kind of a fairly small group of researchers, but it's getting input from a kind of fairly large number of places. On top of that, you have client implementations. And I mean, Geth, Parity, Aleph, Trinity, and Harmony are kind of the 5 big implementations of Ethereum 1.0. But then there's also many implementations of Ethereum 2.0 as well, right? So there's one made in Python. There's one by a company called Prismatic Labs made in Go. There's one called Lighthouse made in Rust. I believe there's one made by Consensus, and then there's might be one or two made by other companies. So it is a kind of multi-client ecosystem right from the start. Right, and for 2.0, kind of the Ethereum Foundation also made this decision that the kind of quote reference clients that we're building is, in some sense, one that's kind of designed to lose in the actual market. So basically the Python clients, right? And the Python client is great, but Python is kind of inherently a fairly slow language, right? And so you would just expect there to be like people that want something faster and something that's kind of closer to optimal. And the goal is that like the client developed by the Ethereum Foundation is meant to kind of serve as a kind of educational tool, as a way for people to learn, as a way for people to like also, you know, use and interact with the network, but it's not it's deliberately intended not to become a kind of monopoly winning client that everyone uses, right? Because we believe that kind of single client hegemony kind of ecosystems are not healthy. And so, you know, you have Prismatic, we have Lighthouse, and like all of these different groups that are all developing clients by themselves too. So this is from a tweet that was made by, I believe, the CEO of Prismatic Labs about a couple of weeks ago. And basically, they have an implementation of the proof-of-stake beacon chain that's like, I mean, it's in terms of like protocol implementation, it's basically ready, right? So in terms of protocol implementation, like there are multiple implementations now that are 90% ready. The thing that is probably less ready is testing, peer-to-peer networking, the fork choice rule, how clients talk to each other, building a test network, and kind of more of these logistical details like that. And you know, these are things that kind of the different clients are very actively working on right now. Right? So things that are still left. Number one, kind of 100% finalizing the spec. So right now the spec is maybe 80% finalized, but there's still 20% that's kind of left to go. And to be honest, we're not kind of really hurrying on it very fast. Basically, the reason is that, like, number one, it's good to have more time to think, but also number two, like, there's still so much more that needs to be done on the development side than on the research. So most of what has not yet been done is basically slashing conditions, right? Basically, like, the rules for penalizing validators that misbehave. Formal verification of the mini spec is in progress, but not yet completed. More development, so development of all of these different implementations, a testnet, and obviously just tests in general. We're starting to kind of develop a cross-client testing suite, so a testing suite that anyone building a client can kind of check their client against, and that's something that will hopefully kind of get all of the clients to kind of comply with and talk to each other more easily. Security audits of the code. So at this point, the code is not even mature enough to security audit, but it will be fairly soon. And after all of this release, right? So this is basically what the kind of roadmap for at least Casper and sharding looks like at this point. In general, I would probably say that sharding or Casper is still kind of very significantly ahead of sharding, and part of the reason is that there are kind of parts Casper is a dependency of sharding, so you basically can't have the sharding system without the Casper system being in place. Part of it is that the needs of sharding are kind of fundamentally more complex, so the peer-to-peer network is probably a very big piece. Part of it is also that just sharding kind of adds more complexity. So realistically, Casper will kind of be ready for use before sharding is, but like we at this point, like I personally would actually think that Casper or sorry, sharding is like at least conceptually probably surprisingly kind of simpler than a lot of people think. So it is on its way and it will get there. So thank you, and more questions. Yay, thank you. No.
Thank you, Vitalik. I think that you should have like some water.
Oh yes.
I think there's a lot of like. Can I have a seat? There's a lot of information out there from Vitalik's side, very promising, and I think that like people may need like for a few time to really digest those information.
If you want to learn more about any slide, like I encourage you to have had the foresight to take pictures of all of them, and that you can like go to the links and like actually read things. It's it is all open.
I think maybe later on we can spread out the
Definitely share
presentation
the
to
slides,
the Ethereum communities. Also, like, is there anyone who have a question on what? Okay, we need to wait for the micro. Because like Vietnamese is that set up if without the microphone and without the mic, then they cannot hear anything.
Just start asking questions and I'll repeat them.
Okay.
So Casper is great, and a lot of, a lot of information and complicated. Actually, I spent quite a lot of time read through the whole Casper design and really understand. But there's still some missing bit. From the slide, first one is can you a little bit explain how the random number generator work quickly? So second question is you are mentioning about the proof of custody. So that is something really missing from my mind, and I understand from just say that you have the computation verification every single month. So why 1 month? So what is the design? The next question is about the virtual machine, the new virtual machine you say. So is there any requirement from the hardware specification and also the software, to upgrade from EVM to the new VM you say, and is there any parallelism mechanism applied to the new VM?
Sure. So regarding proofs of custody, like basically the idea is right that like every month a node kind of commits to a key, and then the node or the validator uses that key in order to do this proof of custody calculation, and then at the end of the month publishes the key, and then kind of anyone else can check over their work. So the motivation behind this is that, like, first of all, we want to kind of have this computation to make it risky for nodes to kind of vote on blocks without actually verifying that they're available and without actually downloading the data themselves. And like basically this is because every single node's proof of custody calculation will be different, right? So if someone else runs it for you, they might get a 0, but if you run it with your seed, you might get a 1. So the idea there is, now why 1 month and not less and not more? Like really it doesn't matter that much. I guess like the longer the period is, the less overhead the protocol has. But like if the period is too long, then like it needs to be shorter than the period that validators have to wait in order to withdraw their deposits, right? So that's the only limitation. Regarding kind of upgrade like EVM to WebAssembly, I mean, like first of all, like it's so WebAssembly will be part of kind of the new spec and not part of the old spec, right? So it is fairly like the two are kind of fairly separate. I don't think there will be like I have thought about this, and I don't think like there is much value in kind of parallelizing WebAssembly itself. Like basically the reason being that there is already parallelization across the network in the form of having many different shards and nodes having to run many different shards at the same time, right? So like I would guess that like even if just because of sharding the kind of CPU cores of many nodes will already be kind of fully used, right? So there would be a kind of just the benefit would probably not be worth the complexity of adding like your built-in parallelization on that level.
And about my first question is the quickly explain about the random numbers.
Oh
generator.
yes. Okay. So right now, like in the spec, there basically is nothing, but that's the intention in the kind of long run is to combine two mechanisms. One of them is RANDAO, where basically validators needs to kind of pre-commit hashes and then reveal numbers as part of creating a block. The other part is the VDF, where basically the idea is that when the validator reveals the RANDAO seed, then after that, like anyone can, like that RANDAO seed is combined together with values that are committed to in previous blocks. And all of that data put together is then used as the seed of the VDF calculation. And the VDF calculation is kind of targeted so that it would take, say, like 10 minutes to compute, right? And so, like, whoever can compute the VDF first would be able to publish the VDF result, and they would get some small reward for it, and the VDF result would be used as the random number for the next round.
Okay, thank you.
Mm-hmm. Yeah, thanks, Luke. Is there anyone else? Oh yeah, I think that's like.
So in the current spec, probably a few minutes. In the long term, we have this interesting idea of kind of layer 2 execution engines that I did not even have time to go into here. But the idea of layer 2 execution engines is basically that you can create kind of second layer protocols that are kind of different sets of execution rules, so like different protocols for running transactions that go on the same Ethereum chain. And what you can do is you can have kind of bridge contracts, right, where you send your Ether to a bridge contract, and then after that, the Ether is kind of controlled by the layer 2 execution engine. And then the bridge contract has some way of verifying. So for example, it could be a snark, right? Verifying the results of this layer 2 execution. And then like if the layer 2 execution says that you have some ETH, then you get the ETH back. I had this recent blog post on vitalik.ca, my website, where I talk about, I think it's like, the title is something like layer 1 should be innovative in the short term, but less in the long term. And I kind of have a description of that. So one of the things that you can do inside of a layer 2 execution engine is you can use kind of apply some of our ideas for synchronous cross-shard transactions. And with synchronous cross-shard transactions, you would be able to send Ether from one shard to another within a few seconds.
Hi, I have two questions regarding the private blockchains.
Mm-hmm.
Yeah, the first question is that because my clients, they are working together as a group and they do kind of B2B businesses. So my first question is that can I use your sharing mechanism to separate our clients into different groups because they want to, there some kind of privacy for their data.
So sharding isn't about privacy, right? Because like in this design, every node still sees every shard. So if you want a kind of partially connected blockchain that preserves privacy better, I would probably recommend looking into Plasma.
Okay. The second question is regarding also in terms of the B2B transactions, because they're doing those kind of transactions with like purchase and quotations, purchase order, payment, and invoices.
Right.
So are you going to expand your platform to include that kind of data? Because now it seems that you want to minimize the data to put on the blockchains. So other things like the data regarding the purchase, process, procurements, many other kind of data, maybe.
So the question is like, can you put other kinds of data on the blockchain?
Sure,
I mean, if that's the question, the answer is yes. But like, Oh, is the volume? So, like, one of the goals of sharding, right, is that the kind of the capacity of the blockchain will increase to the point where, at least until the blockchain goes up to like having 1 billion users, you won't really have to worry as much about kind of optimization. Okay. Right.
Okay, so may I have a question in the second item about the formal verification?
Yeah.
So could you please explain what is the main area, for example, in a consensus protocol or in a smart contract? You think you need to formal verification?
Sure. So for the base protocol,
Yeah.
Our formal verification is focusing on proving the kind of safety and liveness claims of the consensus algorithm. So if you go to the link in the post about the mini spec, basically, like, you can, if you go back through the and look through this, then like you'll see the kind of exact claims that we're trying to prove, right?
Nice.
The outside of kind of the base protocol, I think smart contracts are definitely a very important area to formally verify. And I know there are kind of more and more smart contracts that are being formally verified right now.
I see. So thank you.
Vitalik, I haven't seen you for 4 years. I saw you in Vancouver in 2015. I just want to say thank you for your work. It's so much appreciated. You've got a great deal of love coming at you from around the world. I just want to say thank you so much for your time and for your work and your thoughts.
Thank you.
I think we have like about 2 left questions before Vitalik have to go. The guy over there.
So hi, Vitalik.
Mm-hmm.
Can I ask a question about Ethereum Virtual Machine?
Sure.
So I'm using the sidechain and that's using virtual machine, Ethereum Virtual Machine. But I developed a lot of smart contract, and I face problem with the virtual machine have the problem with the limit cycle. Ethereum Virtual Machine have the problem with the limit cycle. So when I increase a new feature of smart contract, I face that.
So you're
problem.
building contracts and the execution kind of went above the gas limit?
Yes.
So my instinct is that unless you're doing like advanced cryptography inside of there, if your contracts are exceeding the gas limit, you're probably doing it wrong, right? Because like in general, like making smart contracts that are very, very complex can also is a huge risk to security, right? So you want your smart contracts to be kind of as simple and small and like modular as possible. Now, in the long term, like WebAssembly will be a more efficient virtual machine. But like in general, like I would still probably say that I would encourage looking into kind of cutting down the size and increasing the efficiency of the contracts as well.
Yes, and in that smart contract have a limit of size of code, so that means limit of bytecode. When
so right now in the current Ethereum, the limit is 24,000 bytes. In Ethereum 2.0, there definitely will be a limit as well. I mean, not sure what the exact value is.
Yes, and WebAssembly can solve that problem.
Well, WebAssembly is not like the code size will probably be similar to the code size of EVM. So don't expect kind of any technology to be able to give you like extremely large smart contracts on the blockchain, right? Because and like in general, I feel like trying to make like very, very big smart contracts and push them all on the blockchain is probably not even the correct way to go.
Yes. And in slide you saw that it will be released very soon. So when it will be released?
Sorry, when will what be released?
WebAssembly.
So there will be a test net, I believe, in a month, but I'm not sure.
Okay, thank you.
Okay, thanks. Yeah, I think for the last question, yeah. I think this guy. Okay.
My question is about the transaction performance and latency with sharding. Okay, as you said, you have 1024 shards, I guess.
Yes.
And you said that cross-shard transaction takes about 7 minutes in order to confirm the transaction. And I guess if you have 1024 shards, the majority of transactions in the network would be cross-chart transaction.
Right.
And if in the case, does it improve
depends.
the transaction latency or sorry?
So first of all, like it depends, right? So for example, at the beginning, I definitely expect like every ERC20 token to be based within one shard. So for example, like ERC20 tokens, except possibly the very large ones, will all be within a shard. Like participation in like specific kinds of specific dApps would probably be within one shard. So I do expect many kinds of activity to be in a shard. But the longer term solution is definitely to try to kind of look at layer 2 execution engines and use those as kind of the framework for making cross-shard transactions more efficient. And there definitely are ways to do it.
Thank you.
Okay, yeah, thank you very much, guys. I think now it's time for you. Yeah, you have to go. From like FPT side, and I think Mr. Viet have like some small gift I want to send you.
Physical assets. So a physical assets for visitor one. Thank you. Thank you.
Thank you very much. Thanks for coming. Yeah.
We started with one core problem, and the core problem was simple. How do we help women commute safely across the region? That was why we created Grab 6 years ago. We are in the most exciting, most dynamic space there is. Ride-hailing was actually the fastest growth among internet users. We're in about 1 in 7 smartphones across Southeast Asia. Beyond mobility, what can we do for you? Our vision has gotten bigger. Our mission has gotten much bigger. We actually felt that, hey, that's not enough. We're actually even better at creating millions of income opportunities.
Tanahnya kering, jadi banyak yang nganggur. Jadi agen kudo, kita bisa jual pulsa, listrik, bisa nabung beli motor.
But that's not enough for us. 6 million is not enough. We believe we can go from 6 million to 20 million, from 20 million to 50 million, from 50 million to 100 million micro-entrepreneurs. That is our vision of this part of the world. We together can really take millions of people in this part of the world and move them to a new economic reality.
How do you win customers? It's not by thinking, hey, I can only serve them with transport. You can't. You need food, you need payments, you need logistics, you need hyper massive localization. These are the people who really matter to us, and that's what excites us.
Now, it's time for us to pay it forward. We see our chance to give back. How do we think about using Grab, leveraging Grab as a launch pad for your startup?
We were an app that just hailed a taxi. Today we commute, we provide food, you can pay, you provide your e-commerce deliveries, all in one app.